Hey guys, I wanted to make another video about standard deviation and being able to interpret graphs with standard error bars on them. So what I'm going to do is I'm going to use the example of something called the wasting disease in West Coast starfish. So if you just Google wasting disease in West Coast starfish, you can get a whole bunch of pictures of what they look like healthy. So there's like a healthy looking starfish, a couple of them. But on the right, that guy has wasting disease. So what it does is it causes them to lose limbs, and they become, like if you were to actually measure them, they're smaller in size. They think they got a handle on this. They think that it's some kind of virus that got to the starfish, and the population is starting to come back. But what I'm going to do is give you guys two data sets. One just has 5 measurements, 5 starfish 10 years ago. And then last week we have 5 starfish that were measured. So the sample sizes are really small, but that's kind of besides the point for this one. So anyway, it would be really simple just to find the average for this. And then we can compare the averages. And probably if we did the averages, we're going to see that last week's measurements are going to average out to be smaller than 10 years ago. But we want to get a little bit more analytical than that. So let's do that first. What I'm going to do is I'm going to go through this entire example of finding standard deviation and standard error with these starfish. And then when I'm done, you guys will do the same thing for last week's starfish. And then you're going to graph those and turn that graph into me. So I'm going to start off with the average for those from 10 years ago. So there's my 5 starfish. So we got 12.1 plus 13.2 plus 12.8 plus 12.2 plus 11.9. Divide that by 5. So we would average, if we stick with sig figs, we're going to say 12.4. We have an average of 12.4 centimeters. Okay, so we're going to use that to determine something called standard deviation. And standard deviation is symbolized by this theta symbol. And from watching the Bozeman video, this is the equation that we use to determine standard deviation. So all of these variables in here, we got the theta is standard deviation, the sigma is the sum, we got the initial data point and the average data point, and then we have sample size and degrees of freedom. So in this case, we're using degrees of freedom because we are not sampling the entire population, we're just sampling a portion of it. If we had the entire population, then we would use n, not n minus 1. So for example, if you had 1,000 fruit flies and you tested the entire population, you would use n. If you only tested 750 of those 1,000, then you would do 750 minus 1. So that's the difference there. Okay, so what we're going to do is we're going to find standard deviation for these starfish. So I'm going to do this part of the calculation, sigma, which is the sum of the initial data point minus the average squared. So I've done that already on the back, and you can do this on the back too. But see, here's all my data points. So there's my 5 data points that I just averaged. There is the average, and we're squaring that. Okay, so we'll just do one of those real quick. So we got 12.1 minus 12.4, and we square that, and we get 0.09. So I'm rounding that to 0.1 because of sig figs, right? I'm only allowed, when I'm subtracting, I'm only allowed to have the fewest digits after the decimal. This is 2 digits after the decimal, 0.09. I'm rounding that to 1 digit after the decimal. So here's all my answers. And if I add those up, so I'm adding those 5 values up, the sum of those 5 values is 1.2. Okay, so this part right here is 1.2. 1.2, and since I have 5 starfish, I'm going to subtract that and make it 4. So I'm going to do the square root of 1.2 divided by 4. So I have the square root of 1.2 divided by 4. So I have 0.548, but I'm going to round that. Since I'm dividing, I'm going with the fewest total number of digits, so I'm just going to call that 0.5. 0.5. Okay, so that is my standard deviation, 0.5. So what does that mean? Well, on a curve that looks like this, my average is going to be right in the middle of the curve. And so we said the average was 12.4 centimeters. So this is 12.4 centimeters right here in the average. So that would be my average size starfish 10 years ago. Now, my standard deviation is 0.5. So that means that -1 standard deviation is going to be 0.5 less than that. Well, that's going to be 11.9. And +1 standard deviation is going to be plus 0.5, so it'd be 12.9 centimeters. Okay, so the smallest in this range would be 11.9 centimeters. The average would be 12.4, and the largest in this range would be 12.9. So what we're doing is we're saying that every starfish that falls in this range is considered normal, and that's going to be 68% of all of your data should fall in that normal range. That's 1 standard deviation. So now we can see that the range for normal is 11.9 centimeters to 12.9 centimeters. So you have some small ones, some medium ones, and some large ones, and we have everything in between. So that is standard deviation. Now I could go to 2 standard deviations. I could take away another standard deviation, 0.5 from 11.9, that's 11.4. 12.9 plus 0.5, that'd be 13.4. So now everything in, that's plus 2 standard deviations. Everything in this entire area here is, that's 2 standard deviations worth of data. So what we call normal, though, is within 1 standard deviation. And you can go to 3 standard deviations and 4 standard deviations, but you start seeing less and less individuals because they're extreme outliers. Okay, so let's look at the range with 2 standard deviations. So we can go from 11.4 to 13.4. So it's a much larger range because we're talking about 2 standard deviations. But we're going to stick with the normal range for this discussion. Okay, so the normal range. So in this worksheet that you have, the normal range is from 11.9 centimeters to 12.9 centimeters. And so you guys are going to do the same thing with the starfish from last week. All right, now let's talk about standard error of the mean. So standard error of the mean is a pretty simple calculation. So we're going to take our standard deviation value that we already calculated, and we're going to divide that by the square root of the sample size. Not the degrees of freedom, but the actual sample size of 5. So this is 10 years ago. Okay, so our standard deviation was 0.5, and our sample size is 5, so square root of 5. Okay, so 0.5 divided by the square root of 5. So we get, again, we're using 1 digit, so 0.2. 0.2. So the standard error of the mean is 0.2. Remember, that is a plus or minus value. So the average size of the starfish was 12.4. So 12.4, and we say that plus or minus 0.2 centimeters. Okay, so that's the standard error. This average is based on just 5 starfish, so that could be off by plus or minus 0.2 centimeters. Okay, so how would you graph that? All right, well, let me pull up a Google Sheet. Nope, deleted it. Okay, hold on just a second. Google Sheet. Wrong account. Actually, it should. Sorry, I had this pulled up and I don't know where it went. So let's see. This is it. There we go. Okay. All right, so here's how I'm setting up this Google Sheet, right? So I just found my average of the starfish 10 years ago is 12.4 centimeters. You guys are gonna find the average here, and then you're gonna graph the averages, but we're gonna add error bars to that. So I'm gonna highlight this information here, and we're gonna insert a chart. We want a bar chart for this. So this only has one piece of data right now. So let me just throw in another piece of data there. Let's say that the average is just going to be 10. I don't know what it's going to be, but let's say it was 10. And I'll graph that so we can see the 2 bars. Okay, insert chart. Okay, let's make that a column chart. All right, so obviously this is going to be smaller. This is last week's starfish versus this week's. Now I just made this red bar up, so you guys have to actually calculate that out. But I'm going to show you how to put that standard error bar in there. So let's go to customize, and we want to go to series. So I'm going to customize and series. And remember, I don't want to apply my error bar to all the series, just the one I'm working with. So we're doing 10 years ago, an error bar. And remember that we figured out the standard error of the mean was 0.2 centimeters. So I'm going to change that value to 0.2 centimeters. And remember that I also want this to be constant. I don't want that to be a percent. So now look at that tiny little error bar. So that's pretty good when you have a small error bar. Now you guys are going to do the same thing for last week's starfish, and you're going to see a different error bar. It's going to be a different size. So the final question is there a statistical, is there a difference, like a statistic difference between those two groups? And remember, if those error bars are overlapping, you say, yes, there is, sorry, I did that again. If they're overlapping, no, there is no statistical difference between the two groups. If they're not overlapping, then yes, there is a difference between those. So that's what you're doing on this last question. But I want you to explain this with more than just saying, yeah, the bars overlap, or no, they don't overlap. I want you to do a little calculation. Calculate, since we know the average is 12.4, subtract the standard error, 0.2. Do the same thing here, except you're going to do the maximum. So whatever this average turns out to be, add the maximum value to it, and then compare the two values that you come up with. That'll help you determine a little bit more analytically whether or not there is a statistical difference between these groups or not.